Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given this op-amp based circuit, and here we have been given that both op-amps A1 and A2 are the ideal op-amps. But here, this op-amp A1 has an offset voltage of a 1 millivolt. So here, we have been asked to find the output voltages Vo1 and the Vo2 whenever this input voltage Vin is equal to 0. So let us find that. So as you know, for the ideal op-amp, when both the input terminals are at the same voltage level, then the output of the op-amp should remain 0. But actually if you see, then the sum voltage will appear at the output. So this offset voltage is the input voltage that we need to apply between the op-amp terminals so that the output of the op-amp will become 0. So here, this VOS is the offset voltage for the op-amp A1. So here, we have been asked to find the output voltage Vo1 and the Vo2 whenever this input voltage Vin is equal to 0. So here if you observe, then the one input terminal of this VOS is connected at this node, and the other terminal is connected at the inverting node. And here if you observe, then both the op-amps are operating with the negative feedback. That means here we can apply the concept of the virtual ground. So here if you observe for this op-amp A1, then the non-inverting terminal is at the ground potential. That means here this inverting terminal will also be at the ground potential. So we can say that the voltage at this node is equal to VOS. So let's say this node is equal to node A, while this node is equal to node B. And this node B will be at the ground potential. Because for this op-amp A2, if you see the non-inverting terminal, then it is at the ground potential. That means here, this node B will be at the ground potential, while the voltage at this node A will be equal to VOS. So now, let us apply the KCL at this node A. So applying the KCL, we can write this VOS divided by R, that is this current, plus VOS minus Vo1 divided by R, that is this current, plus VOS minus 0 divided by R, that is this current, should be equal to 0. That means the summation of all the outgoing currents should be equal to 0. Or from this we can say that this 3 times VOS is equal to Vo1. So here we have been given that this VOS for this op-amp A1 is equal to 1 millivolt. So from this we can say that this output voltage Vo1 is equal to 3 millivolt. So in this way we found the output voltage Vo1. So similarly, by applying the KCL at this node B, let us find the output voltage Vo2. So applying the KCL at this node B, we can write this 0 minus Vo2 divided by R, that is this current, plus 0 minus VOS divided by R, that is this current, should be equal to 0. So from this we can say that this Vo2 is equal to minus VOS. And we know that this VOS is equal to 1 millivolt. So from this we can say that this output voltage Vo2 is equal to minus 1 millivolt. So in this way, we also got this output voltage Vo2. That means for the given circuit, this Vo1 is equal to 3 millivolt, while this Vo2 is equal to minus 1 millivolt. And therefore, for the given question, this A is the correct answer.